So that means let's talk about correlations in Jamovi. So I'm going to give you an example of a research question, and we're going to tackle it using Jamovi here. So there will be a data set in in Canvas. There will possibly be more than one data sets, but I'll tell you the data set that you need for each one of these examples as we go through. So get ready. So we're going to be calculating a Pearson correlation. And I tried to come up with an example here that was kind of a little different, and I know I have some nursing students, so I wanted to do something that was kind of related to both psychology and nursing. This would be a research question that would be very applicable to both groups. So I'm a researcher, and I want to know if there is an association between medication administration errors. That means I gave the patient the wrong medicine. So I want to know if there is an association between that making that error and anxiety, sleep quality, and or clinical preparedness. And by clinical preparedness, I mean how well am I prepared to do my job, clinically speaking, as a nurse. So I have three variables that I'm measuring here. So I'm going to do three different correlations. So this is my research question. Is there an association between medication administration errors and anxiety, sleep quality, and or clinical preparedness? So here's the scenario. Nursing students in clinical rotations often face demanding schedules, including overnight shifts, back-to-back clinicals. That's where they have to go and work on in a clinical area to see a certain like med surge or psych or labor and delivery, right? They're learning those things related to that particular area of nursing. And of course, they've got coursework that they've got to keep up with and lots of deadlines. So in a collaborative study between the psychology and nursing departments, researchers investigated whether sleep quality, so how well are you sleeping, and state anxiety is how anxious are you right now, are those things related to errors in giving medications. And we're working in a simulated hospital setting here, so we're not actually working on patients. So participants included 100 nursing students. They completed a validated sleep quality index. So they reported on how well they feel their sleep is, right? They also did a state anxiety inventory. So that means how anxious are you right now? And they participated in a timed medication administration simulation. So they had patients, they had orders for medications, they had to check MARS, they had to go do all of the things that they have to do to get the medications to be able to give to their patients without making errors. And that was the thing that they were observing. They were observing how many procedural errors were recorded. So the researchers also looked at clinical preparedness based on a self-reported checklist of completed lab skills, safety trainings, and mock simulations. So on a self-reported scale, how did these nurses feel about their clinical preparedness? Were they prepared to be working in the clinical setting, or were they not? So the aim of the study was to explore how psychological and behavioral factors might increase or reduce the likelihood of making medication errors in clinical environments. All right, so there's your setup. Let's talk about our hypotheses first. So remember the purpose of hypotheses and establishing those hypotheses in psychology and research methods in psychology is to know what is an effect and what is not an effect, and we're pessimistic. We always assume there is no effect, okay? So in a correlation, we're assuming that there is no correlation between any of our variables. So we're going to list out our three null hypotheses. Hypothesis 1 says there's no correlation between sleep quality and the number of medication errors. So how well I slept last night has nothing to do with me making errors. And it may be true, it may not. I don't know. We'll have to find out. The second one is that there is no correlation between state anxiety scores and the number of medication errors. So how anxious you feel right now at this moment doesn't necessarily have a bearing on whether or not you make a medical administration, an error while giving out medication. The last one is that self-reported score about clinical preparedness. How well do you feel, clinically speaking, to be doing your job in a clinical setting? And how well that rating correlates with the number of errors that you might make. So those are our null hypotheses. Let's go over the alternatives. So if you notice, every one of these alternatives has a direction. Okay? So the first one says there is a positive correlation between poor sleep quality and the number of medication errors. I want you to understand that by saying positive, I am not talking about this being a happy or a good thing. By positive, what I mean is as the number of medication errors increases, the poor sleep is going to, your rating of poor sleep is going to increase. So my rating scale for poor sleep, 0 means I've got wonderful sleep, and 10 might mean I have terrible, horrible, poor sleep. So as that score on sleep quality, poor sleep quality goes up, what happens to the medication errors? They also go up. And again, we're testing this. I'm not claiming this is true. This is just our hypothesis at the moment. The second hypothesis is that there is a positive correlation between state anxiety scores and the number of medication errors. Same thing. As your anxiety level increases, the number of medication errors you make would increase as well, according to this. And then the last one, there is a negative correlation between clinical preparedness and the number of medication errors. So what that means is as the clinical preparedness increases, the more prepared you are, what happens to the number of errors? They decrease. And that makes sense. If you're being trained on something and you have a protocol that you have to follow, the better trained you are on that protocol means the less number of errors you're going to make. So our next step would be to determine the decision criteria. And I included the thing from the book because I wanted you to see how that correlates to the results that you get in Jamovi. But when I ask you to do this on a test problem or an assignment, I want you to focus on that alpha level and our p-value for our probability to reject or retain. So our alpha level is going to be p equals 0.05. Unless I tell you otherwise, that is what I want you to assume is our alpha level in any problem in this class. And if you noticed on those hypotheses, they were all specifically stating either a positive or a negative relationship. So these are all one-tailed. So if I were doing this by hand, I would need to define my critical level. So I would take my Pearson table and I would go to alpha level of 0.05 for a one-tailed test. See, I'm moving this time because last time it was in a 2. And then my degrees of freedom are equal to n minus 2. So there were 100 participants in the study, and 100 minus 2 is 98. So I'm going to round up, and I'm going to round back up to 100 here. So there is my critical value, 0.164. So anything above that or anything below negative 0.164 is going to be significant. Do you need to calculate that if you were doing this in Jamovi? No. If you were doing this in Jamovi, when you evaluate your Pearson coefficient, you're going to make a decision based on this alpha level right here. If the alpha level in your results is less than 0.05, you have a significant results. So you've got to be careful when you're interpreting these different statistics. If you noticed your statistic up here, R is greater than that critical value if you're dealing with the R value. If I'm not, and I'm dealing with my p-value, p-values have to be less than the critical value. Why? That distribution we looked at earlier. There's your distribution. Remember, I'm looking for up here. If it's a positive correlation, I'm trying to find out what's going on in this section right there. There's only 5% distributed in that piece right there. P is less than 0.05. So if my probability falls in that little section right there, I'm going to reject the null. So now I want you to open up the data set that says about nursing, I think, or medication errors, one or the other. It's nurses and medication, I think. And it was in Canvas in the materials section there. So open that data set up in Jamovi. And I want you to go to regression. And I know we're not talking about regression, but correlation is found under regression in Jamovi, okay? I want you to go to regression, correlation matrix. And what you're going to do is you're going to move two variables over at a time. Now, you could move multiple variables, but it's not going to help us in this situation because I have two positive one-tailed tests that I'm going to do and one negative test. And by positive and negative tests, I mean my results that I'm looking at is positive or negative. So if I threw them all in there, there's a spot in there where I have to tell Jamovi that I'm only doing one-tailed, and it would mess it up if I did this in multiple comparisons. So we're going to test each hypothesis individually. The first hypothesis that we listed was that there is no correlation between poor sleep quality and the number of medication errors. So I want you to move the sleep quality score and the medication errors over into that box on the right hand side. Now I need you to make sure you've got some things checked at the bottom. Under the kind of test, you're going to run a Pearson, and that's going to be under correlation coefficients. So make sure you've got Pearson, not Spearman, and not the other one in there. I think it's Tau something. Under the hypothesis, I want you to look at correlated positively because that's what we postulated as an alternative hypothesis, was that if there is no association, we would expect it to be positive, right? Under additional options, I want you to tell it to report significance because that's where you're going to be able to reject or retain the null based on output from Jamovi, okay? And you need it to flag those correlations. Otherwise, you're going to be sitting there trying to figure it out yourself. And, you know, it's not hard, but just this is easier, okay? And then I want you to do the correlation matrix. I want you to tell it to give that to you. Under correlation matrix, I want you to do a plot. And by plot, it's going to give you a scatter plot. So this is what I was telling you here. You're inside that correlation matrix right there. I want you to move over sleep quality and medication errors into this. I call it the variable box. It doesn't really have any label, but it's what those are. They're variables. Under correlation coefficients, make sure you have Pearson checked. Under hypothesis, this is important, make sure you've got correlated positively checked. Ignore that for now. I'll get it on the next slide. I just had too much going on here. Alright, so over here, you want to make sure that it's going to report and flag. So report and flag. It just makes it easier for you to determine what is significant or not. And then over here, make sure you, under plots, hit correlation matrix. because it's going to give us a scatter plot. And I want you to look at the scatter plots before we look at the significance. So go ahead and look at your results on your right hand side in that calculations thing. I want you to scroll down and I want you to find the scatter plot. So your scatter plot should look something like this. Now, why does it look a little funky? Well, it looks a little funky because of the way the data are set up, okay? But at the same time, you are able to get this line, and that is what we are interested in looking at right now. Do you see a positive slope to that line? I do. So the first thing you would do is look at that scatter plot. You're going to look at that line of best fit, and you can see that there's a positive slope. Although, personally, to me, it does not appear to be very large. If I compared it to something else, I might say it was not very sloped at all. It's a very mild slope. I'm just making a general statement. I am not using that statement to qualify a correlation at this time. I'm simply making an observation. That's what scatter plots give us, a descriptive statistic. And I could have run descriptives, but none of that really matters right now. So important, just because I see that there is an association, I am not sure whether or not it is significant. I just want you to eyeball that scatter plot, kind of like a preview, and say, okay, there is a slight relationship there. So let's go and see if it is significant or not. So the thing you're going to look at in Jamovi is your significance and your R. Okay, so our Pearson's R is 0.082. And if we had calculated this by hand, our decision to reject the null would have been based on the idea that your R was greater than 0.164. Where did I get that? I got that from that table, okay? But I've spent the last 45 minutes telling you that in Jamovi, you don't have to worry about that, because Jamovi is going to tell you that we're looking at that p-value. So up here, if I take my R is smaller than the critical value of 0.164. Great. How you evaluate that in Jamovi? Looking at this p-value. Okay? We set our alpha level at 0.05. So I've got to look at this p-value right here, and my p-value is 0.208. So when do I reject? I reject when it is way less than, and it is not way less than. I get a p of 0.208 is greater than p equals 0.5. Is that significant? Absolutely not. It is not significant. So for that first hypothesis, what are we going to do? We are going to retain the null. And by retain the null, we're going to say, hey, guess what? My null hypothesis is true. There was no significant correlation between the two things. Was there a correlation? Absolutely. Was it really small? Absolutely. Was it significant? No, it wasn't. Therefore, remember, hypothesis testing is it's mutually exclusive. I either retain the null or I reject the null. I either accept the alternative or reject the alternative. That's what we just did. We rejected the alternative because why? It wasn't true. What was true? The correlation was not significant. Now let's go on to our second correlation and see what we get there. So our second analysis that we're going to do is to compare anxiety with medication errors. So this time I want you to move anxiety and medication errors into the variables box, and make sure you move out sleep quality. Get it out of there. Otherwise you're going to get some funky mess that's not going to look like mine. I want you to keep the same checked boxes underneath, because we said for that second hypothesis, we said it was also positive. It was a we were hypothesizing that if there is a relationship, it is going to be a positive correlation. So keep your hypothesis correlated positively. Make sure your correlation coefficient is still Pearson. Make sure your additional options are report significance and flag significant correlations, and then make sure you plot your correlation matrix. And the first thing I want you to do is scroll down and look at your scatter plot. So let's do that. So here's a scatter plot for that variable here. This is anxiety and medication errors. And again, I see a positive relationship that indicates a positive correlation exists between these two variables. Is there a correlation? Yes. Is it significant? Probably not. And I'm basing my probably not on my last results. But again, I can't make that decision yet because I don't know if that is statistically significant or not. So what do I need to look at? I need to look at my results. So if you scroll up, your correlation matrix up there is going to tell me the correlation between med errors and anxiety score. And I'm going to evaluate it first like we had calculated this by hand. And if we calculated it by hand, we would have got that our Pearson's R was 0.96. And based on the critical value for the R, to reject that null, my R would have to be greater than 0.164. 0.096 is not greater than that value. So it's less than the critical value. So I automatically know that I'm going to retain my null. But remember, in Jamovi, we're going to be concerned with this p-value right here. I have a p-value of 0.17. I need that p-value to be less than 0.05. It is not. My p-value is 0.170, which is again way greater than the alpha level of 0.05. So what do? Retain the null. The null is true. The null says there's no relationship, there's no correlation. I am saying that's true. I'm affirming it. So here's where we are. We've tested 2 out of our 3 hypotheses. We said there's no significant correlation between sleep quality, poor sleep quality, and the number of medication errors. We've also said there's no significant correlation between state anxiety, that means how anxious are you right now, and your number of medication errors. I have one more hypothesis to test, and that was that there is no correlation between my clinical preparedness and medication administration errors. All right, so clear out any variables you have in your variable box, and this time I want you to enter the variables clinical preparedness and medication errors. Okay, and I want you to keep everything checked underneath except for under hypothesis. I need you to go in there and I need you to change it to correlated negatively, because that's what our hypothesis said. Our hypothesis said that if there is a relationship, it is going to be correlated negatively. Keep all the rest of the stuff the same, let it go, and let's look at our scatter plot. Alright, so you should have gotten a scatter plot that looks like this, right? And I see a negative, oh, I cannot draw a straight line with this mouse, I apologize. I see a negative linear relationship this time. To me, the slope, while negative, still looks bigger than the slope for the other two, but that's just me eyeballing it here. I still have no idea if that slope is significant. So again, I see a negative correlation. That means this time as your clinical score your clinical preparedness score decreases, so the less clinically prepared you feel, what happens to your medication errors? They increase. Now that's the same thing as saying, as my clinical preparedness score increases, what happens to my medication errors? They decrease. Okay? So even though it looks like the slope is more significant than the previous variables, I won't know that until I have made a determination about that significance using the critical values that I have set for R and for my alpha level. So here is the correlation matrix for that comparison. I'm looking at clinical preparedness score and medication errors. I have a Pearson's R of negative 0.415, and I've got some asterisks right there. That's going to be important. And then I have a p-value of less than 0.001. And if you remember, our critical p-value was less than 0.05. Okay? So our critical, we talked about this earlier, this is if I was calculating it by hand. If I calculated it by hand, I would have gotten an R value of negative 0.415. Our critical was 0.164. If I drew a number line out, and I put 0 right here, and I put my critical value of 0.164 right here, negative 0.415 is going to lie on the left-hand side of my critical value, which means that I am going to have a significant difference this time. Okay? So this is it's negative numbers. That's a hard concept for people to understand, but as the number gets greater on the left-hand side, it's actually smaller. All right? So that's why when you're using Jamovi, I want you to go with this. Use the flagged significant values because it's much easier. We got a calculated, this is our R right here, and we can correlate that to a p-value of less than 0.001, which is definitely less than our alpha level of 0.05. So what am I going to do? This time I'm going to reject the null because there's a significant negative correlation between those two variables. And if I pull up that chart we went over earlier, if I look at Cohen's rule, my R is a negative 0.415, which puts it between medium and large. So there's a pretty large effect. Okay, it's significant and it's a pretty large one. So let's update our hypotheses. We have retaining the null for the first and the second one. There was no correlation between poor sleep quality and the number of medication errors. There was no correlation between state anxiety scores and the number of medication errors, but there was a negative correlation between clinical preparedness and the number of medication errors. So I retained my first two, and I rejected the null for the third. Let's put it into plain English. There's no significant increase in medication errors as poor sleep quality increases. So the worse you sleep, it's not likely that your medication errors are going to be going up. Again, by saying that, I am not implying causation. I am noting a pattern of relationships between two variables. For state anxiety scores, same thing. There was no significant increase in medication errors as your anxiety level went up. But there was a significant difference when I looked at medical errors as a function of clinical preparedness. So there is a decrease in medication errors as your clinical preparedness increases. So the more confident you are, because it was a self-score, it was a self-reported score thing, right? So the higher you score yourself in clinical preparedness, being prepared to be a good nurse, the number of times that you make a medication error can be predicted to be lower. And that's what we want. We don't want medication errors. Those are bad things. So the only thing we have left here is to evaluate how would I write this in APA format. And this is a very complicated problem that we went through. It has 3 variables. And I'm not going to give you on the assignments, I'm probably not going to give you 3 at once. I'm going to break it down into smaller ones over the assignments. No big deal, right? But I want you to know how to write this, and so I just focused on how to write the one that's significant, and I'll go back later on and show you how to write the other 2. So this is an APA write-up for that significant Pearson correlation. So what would I say in my paper? I would say a Pearson correlation was conducted to examine the relationship between clinical preparedness and medication errors among nursing students. And again, why am I only talking about medication errors? Because it's the only one I want to talk about right now, because this presentation is pushing 2 hours, okay? So there was a significant negative correlation between clinical preparedness scores and medication errors. And what I do is I report that R value, and I put my degrees of freedom in parentheses. So R of 98 degrees of freedom equals negative 0.42. And you're going to report that R from the correlation matrix. When using Jamovi output, though, what we're looking for is that P level. And it told me that my P level is less than 0.001. It is even more stringent than my 0.05. Okay, I said anything less than 0.05 is significant. So this is significant, and it's significant on a one-tailed level because I was only looking for that negative. So we would explain the finding. This finding suggests that higher levels of clinical preparedness are associated with fewer medication administration errors in a simulated clinical setting. Remember, this wasn't an actual setting where they were working with patients. It was simulated. And notice, I did not say being more clinically prepared causes you to make fewer errors. Why? That would be making a causation, and we can't do that. But what I can do is say that the higher clinical scores are associated with fewer medicational errors, because that's what a Pearson correlation does. Okay? So we're going to go over a Spearman, and then I'm going to end this presentation, and you will go and work on your assignment. All right, so we looked at our Pearson correlation. Now we are going to look at a Spearman correlation. So that just means that something on here, one of these variables, is going to be measured using an ordinal scale. Okay? So the setup for this one, the particular scenario I put was an ADHD scenario, and I said, is ADHD symptom severity associated with task completion, sleep disruption, and academic self-efficacy in college students. So, is the severity of your symptoms associated with finishing a task, getting interrupted sleep, or your effectiveness at academics as a college student? So this is what they did. I said researchers surveyed 100 undergraduate students to explore the relationship between ADHD symptom severity and academic functioning. Participants completed a self-report ADHD inventory along with measures of weekly task completion, sleep disruption, and academic self-efficacy. Because some variables were ordinal and relationships might have been expected to be nonlinear, a Spearman correlation was used to examine the possible associations. So remember, nonlinear means it might not be in a straight line, okay? So let's do our null hypotheses. Remember, our null hypotheses are going to tell me that there is no correlation between those two variables of interest. So the first null is that there's no correlation between ADHD symptom severity and task completion scores. The second one is that there's no correlation between ADHD symptom severity, and sleep disruption scores. And then the third one says there's no correlation between ADHD symptom severity and academic self-efficacy. All of our alternative hypotheses are going to be one-tailed. That means I'm looking for a specific direction. They may be positive, they may be negative. So let's look at the first one. It says there's a negative correlation between ADHD symptom severity and task completion scores. So what that means is as my symptoms get more severe, the number of tasks that I complete in a week decreases. And that makes sense from a perspective of thinking about what ADHD is. If I am counting my success as the number of tasks completed, and my ADHD symptomology is causing me to not complete tasks, then I have that negative relationship there. The next one says there is a positive correlation between ADHD symptom severity and sleep disruption scores. So positive means as one increases, the other increases. So that to me makes sense if these are comorbid issues. So my scores on my ADHD symptom severity are going to be increasing, and my sleep disruption is also going to be increasing. Okay? And then the third one, there would be a negative correlation between ADHD symptom severity and academic self-efficacy. So how effective am I academically is going to be negatively correlated with my ADHD symptomology. So if I say my symptoms are severe, I'm going to have a low rating on my effectiveness academically. So we need to establish our decision criteria. Again, we are going to focus on that alpha level. I am going to show you where you would get the critical level. It's the same place you got it the last time, and it's the same levels because I kept the numbers the same. So our critical level is going to be defined as an RS of plus or minus 0.165. So if my RS is positive or negative greater than that 0.165, I'm going to reject my null and say that there is a significant difference. But I want you to focus on that alpha level of P is less than 0.05. And I'm hollering less than because I promise you I'm going to have people who don't know how to do this because y'all don't pay attention. And I'm not fussing. I'm just saying it's real easy, y'all. If that P value is less than 0.05, there's a significant difference. Please find it. So there, right there is your 0.165, your positive for the right side, your negative for the left side. Let's calculate and do your analysis. So go ahead and open up that data file that is in Canvas about ADHD. All right, you're going to go to the same place. You're going to go to regression, correlation matrix. We're going to move over 2 variables at a time. Our first hypothesis is that there is no correlation between ADHD symptom severity and task completion scores. So you're going to move ADHD severity and task completion over to the box on the right-hand side. Then we're going to go over what you need to make sure is clicked underneath. So underneath it, I want you to make sure you've selected Spearman for your correlation coefficient, and I want you to uncheck Pearson, because if you don't, it's going to calculate both of them, and I don't want you to have to sift through all that data. Uncheck Pearson, check Spearman. Under your hypothesis, please select correlated negatively, because that's what we hypothesized, right? And then under additional options, make sure you've got report significance and flag significant correlations checked. And under plot, I want you to select correlation matrix. So there are the 2 variables that we're looking at. Make sure you've selected Spearman and unchecked Pearson. Make sure you've selected correlated negatively. Also, I want you to make sure you've got report significant and flag significant correlations. It makes it easier to read them. And then we want a scatter plot. So select under correlation matrix, select under plot correlation matrix, which is just a fancy word for saying scatter plot. Go ahead and scroll down and look at your results. So you should have gotten some results that look like this. And again, just based on my, eyeballing here, that looks like a pretty nice negative slope. Looks rather linear. Things are clustered tightly around that line. So again, at this point, I can say there is a negative association because of that negative slope. But again, I cannot tell you if it is significant or not, because I have not done anything other than eyeball it at this point. So we already said our Spearman's row, we're going to get negative 0.929. For us to reject that null, that R sub S value must be greater than that. So for our first hypothesis, we rejected the null. So we're going to accept our first alternative hypothesis, which there is a negative correlation between ADHD symptom severity and task completion scores. So let's move on to the next comparison that we're going to do. All right, so the next comparison is going to be our null of there is no correlation between ADHD symptom severity and sleep disruption scores. So if you're following along in Jamovi, go ahead and move those correct values, variables into the right place. So here we need to make sure that we have ADHD severity and sleep disruption in our variable box right there. Then we're looking at those 2 variables. We need to make sure we have Spearman correlation checked. And we're correlating positively this time, I believe. So make sure that you have that checked well. You want to make sure that you have the report and flag significant to make it easier to have that pop out at you. And you want to make sure you've got your correlation matrix under plot selected so you can see your scatter plot. So go ahead and look at the scatter plot. What do you notice about it? So hopefully you will notice from the scatter plot that we have a nice positive slope, a nice tight line there. So on the offset, we can go with these things are more than likely, they are associated with each other. We do not, however, know if it is significant. This is just an eyeball, but just going on the comparisons that we had before, looks like it could be. So let's investigate it and find out. So here we have our correlation matrix for our Spearman's row for ADHD severity and sleep disruption. You can see here you have a nice 0.929, and there's 3 asterisks there. Your degrees of freedom are 98, and your p-value is less than 0.001. So our calculated rho is 0.929. Our critical value was 0.165. So our calculated rho is definitely larger than our critical. There you go right there. Remember, you wouldn't be doing that if you're using Jamovi. You can go by the p-value, which is much easier to me. You don't have to get a book and look all that stuff out. So P equals less than 0.001. It's not giving you an exact value because it's really small, okay? Which is why it defaults. Most statistical programs will do that. They will default to one of these levels. So that at the 3 asterisks down here is one-tailed, and its P is less than 0.001. So we are going to reject the null. There is a positive correlation between ADHD symptom severity and sleep disruption. Okay, so we're going to add that to our list of decisions that we've made on the next slide. Okay, so we moved over ADHD severity and academic self-efficacy. Those are our 2 variables we're looking at. Make sure there's nothing else over in the variable box. Make sure you've clicked on Spearman, and this time it's a negative correlation. It's one-tailed, which is why we're only investigating negative. Make sure you have flag and report selected so it's easier to jump out at you if there's something significant there. And make sure you've selected correlation matrix so you can see your scatter plot. And once you've already got your variables moved, go ahead and look at the scatter plot and see what you can find out. So here's our scatter plot for these 2 variables. You can see that there is, again, a negative slope. It looks pretty intense as far as the slope is concerned. We can make an eyeball of this, not significant until we have looked at the critical values. All right, so here we have our correlation matrix for our last comparison. We're comparing ADHD severity and academic self-efficacy. We have a Spearman's rho of negative 0.895, degrees of freedom 98, and our p-value, again, is less than 0.001. So there is our Spearman's rho. It's negative, so I made a mistake right here. That should be, oh, I don't even remember what it was, but you're going to reject it because it is significant. And there you go. It's going to say it down here. So it is greater than, and this should actually have a negative, and it is greater than that. So go by what you can find in Jamovi, which means you would use your p-value right here. The p-value is less than 0.001 at an alpha level of 0.05. That means we reject the null. There's a negative correlation between ADHD symptom severity and academic self-efficacy. So as your symptom severity increases, your views of being a self-efficacious person would decrease. Okay, I know that's hard to kind of get that, but your thoughts about yourself being an efficient and good academic, a scholar, basically, goes down as your severity of your symptoms increases. So let's look in summary at our 3 hypotheses there. So for our last hypothesis, we also rejected the null. So for all 3, we have rejected the null, and we have rejected the null, and we have adopted our alternative hypotheses as true and correct here. So there's a negative correlation between ADHD symptoms, severity, and task completion scores, positive correlation between severity and sleep disruption, and negative between severity and self-efficacy. All right, guys, so that ends our lecture on correlations, and I'm gonna have a separate video explaining your 2 assignments for this week. If you have any questions about anything, please email me. We're getting towards the end of class. We've only got 2 weeks left, I believe. This is week 5, 6, 7, 8. Yeah, so 2 weeks. So if you have any questions about anything, please reach out and let me know. Y'all are amazing. I'm proud of all the hard work, and keep it up.